Hey guys, what's up? Welcome back to the classroom. It's Mr. Low, and today we're going to discuss on the weighted assessment 2 practice paper that we just done earlier next week, last week, sorry. Okay, so overall I feel that this paper is really easy. It shouldn't be the case, all right? Despite the difficulty in algebra, right? A big part of the paper is algebra. I feel that the way this type of questions that they give is actually ridiculously simple. All right. So if you did score well, this will not be the case for the real weighted assessment and subsequent tests or exams. So do not be complacent. Do not be too proud. Right. For those who didn't really score well, um, don't worry. Okay, there are definitely ways to improve. Okay, how to study mathematics. Later, I will do a quick explanation on how I think mathematics should be studied. All right. So let's get right into it. If you have the scanned copy of your own papers, right? That time after the exam, after the test, sorry, I told you to scan your own work, right? Okay, if you have it, please pull it out, right, so that you can cross refer and you can have a sense of how well you did, yeah. But no worries, I have marked the paper and I will show it to you when we meet again in school. All right, so let's get right into it without further ado. So the first type of question is something that we have done intensive practice the lesson before and on the day itself of the test. Okay, so the whole idea here is there is a set of working as an example given to you, right? And guarantee there are mistakes. Okay, so in this paper, I told you that most of the questions have only one mistake. Yeah. So your whole point, your task is to spot the error, right? And then carry on the working from there or start from the beginning, right? So in this case, the mistake is already given to you as an example, 5n, because yeah, from here you should have rainbow in the 4 to open up the bracket so forth. And this 5n should instead have been 20n. Pardon me. Okay, instead of 5n, it should be 20n because it's 4 times 5n over here. All right. So from there, you can carry on the working, right? So this is the correct one. And then from here, you proceed. All right. So let's move on to the next the first question that you're supposed to have done. Right, so in the first question, this is simplify the four expressions. Okay, now there's a difference between remember between equations and expressions. Okay, let me explain a bit. So you see this equation here. Okay, how do I distinguish? How do I differentiate between an expression and equation? Well, in the equation, as the word suggests, equal equation, you should see in the original question that there is an equal sign in between. Okay, there is an equal sign. But for expressions, there isn't any equal sign. This is the original question. You might say, teacher, there is an equal sign here. No, this equal sign is added in by yourself. It was not originally present in the question. Okay, so what do you do for equation and expression separately? Let me write this down by the side. Okay, now for expression, so I'm going to use the word exp in short form. For expression, you have for instance 2x plus 3 plus 5, right? Something like this. There is no equal sign present in the question. Now what do you get at the end of it? Usually you get another expression. Okay, just that it's a simplified form. So I'm going to do the working here. This equal sign is something that I add in myself. It was not in the question. And if you know how to do quickly, it should be 7x plus 3. And we're done. That's it. Okay. So at the end of the question, usually is a simplify. Okay, usually you'll see this word simplify or, for example, factorize. Okay, so you'll see these two kind of words, these two prompts for dealing with expression. You have an expression right at the start, and you will get another expression that is equivalent, okay, at the end of your working. Now, how about equation? Okay, for equation, you have an equal sign already present in the question. So if I were to use the same example, okay, I'll have equals to something. Let's say is equals to 10, let's say, for example, right? That's equal to 10. Now, what do you expect to have at the end? So let's do through the working. Yeah. Okay, I'm going to simplify the left-hand side. That will give me 7x plus 3 equals to 10. Right. Now, what do we do from here? Remember I used to say, right, for equation, we want to solve for x. Okay, so we want to keep x alone on the left hand side. Okay, so that means I see this plus 3 over here. I'm going to throw over across this equal sign, and as a result, it will change sign. Okay, so what I'm left here is 7x equals to 10x, 10 minus 3, and that gives me 7. So from here we know x equals to 1. Now, what is the difference between an expression question and equation question? For the equation question, at the end of the day, you will get a value of x equals to something. Whereas for expression question, you're not able to calculate what is the value of x, right? It's just an expression. For equation, you are supposed to get x equals to something at the end of the day, right? So therefore, the type of word that you will see, the prompt word that you will see is solve. When you see the word solve, means that you're expected to get some value for x at the end of the day from the original equation given in the question. So that's the difference between expression and equation. Roger? Okay, if you understood, then let's carry on. So this is so very clearly, this in this example, it is an equation, first of all, and you see the prompt word solve. So at the end of the day, I'm expected to get a value of x, n in this case, out of the equation given. For this first question that you attempted, it is a expression. So you see the prompt word simplify, right? So you're just gonna simplify and you get an expression at the end of the day. Okay, so first thing you see there's a bracket. The first thing you should be doing is to rainbow the 6 in. Remember, be careful of the sign in front of the 6. This time it's a positive sign, so no problem. Don't have to worry too much about it. Alright, so let's just rainbow the 6 in, and you get 18k plus 24. Not forgetting the guy behind. Alright, so where's the mistake? Where is the mistake? Yeah, from here to here, no problem. Okay, but from here to here, this guy seems to have forgotten your 24. 24 seems to be forgotten. Okay, so the answer should be 16k plus 24. Now, this is a very common mistake that a lot of you do. Okay, now I'm gonna show you how people write this working wrongly. Okay, so I start from here. 18k plus 24 minus 2k. Okay, so this is the step I'm referring to. Now from here, a lot of you subconsciously know that, okay, I should be dealing with the variable first. So you literally do that step. But again, you abuse the equal sign. You write something like this. Can you see what is going on here? Can you see what this student might be thinking in his or her mind? Very clearly, the student dealt with the k first in his or her mind, but he or she literally wrote it down. And then after dealing with the k, he or she suddenly remembers, okay, I have to, oh, this is wrong, this is a plus, right? I have to remember the 24, so I conveniently just add it in at the end of the working. And you expect the teacher to give you mark, but it's horribly wrong. Why? Because, again, the equal sign is abused. 16k simply is not equals to 16k plus 24. So you all have this habit of, which is nothing wrong, you do things part by part because, well, the question might seem complicated. However, you must be careful of what equal sign means, right? So it means this line over here must be equals to this line. So what is not equal here? You've forgotten your 24, right? If you have written the 24, if you have copied and written over at every line, so this is not relevant, then this will be correct, no problem. So please settle your thinking. Okay, remember, you can do things, you can compartmentalize these things, you can do things, by components, but by parts, but do not forget to copy over whatever the things that you're not dealing with, right? If you leave them alone, you cannot just literally leave them alone in the question, you must carry them over in your working. Okay, so I don't want to see this kind of working again. Let's move on to the next question. Okay, so in this question, you see that, okay, I have another expression, right? So, yeah, rainbow method again. This is a plus in the middle. Yeah, so the first problem and the only problem here is this, right? It should have been 5. Okay, so it's quite simple. You can straight away carry on from here. Not forgetting the plus 7 behind. Okay, so this is quite simple. You deal with the constants, add together, and your variable 15z remains. Pretty simple. Next, a lot of you didn't get this correctly. So you see, again, expression, but this time the prompt is to factorize. Okay, so maybe a few may not be aware of what factorize means. Factorize is, I would say, is the opposite of the rainbow method. So let me explain a bit on this side here. So just now we had an example of something like this. Okay, so after you rainbow this in, it should be 5 plus 15x, yeah? Okay, now this thing is what we call expansion. Okay, it's an example of the procedure of expansion. You can see that I'm opening up brackets, I'm expanding the expression. All right, now the reverse of it is factorization. Okay, now in factorization, what do we do? Literally, we do the opposite. We are given this and we are expected to arrive at this. Okay, you can see that it's the exact opposite. Okay, so one is the thought process of doing this factorization. The key is you look at the terms, each term in the expression, and you find a highest common factor. Remember this? Okay, so in this case, I noticed that 5 and 15 itself, there's a common factor, highest common factor of 5, so I can draw it out. But my question is, are we allowed to draw out the x? The answer is no, clearly, because this term does not contain x. It is not a vector. All right, so here we drew out the 5, and whatever is remaining in the bracket, is such that if I rainbow back the 5 in, I should get back the expression on the left hand side. Okay, so essentially, this 5 over here, you take out a 5, you have 1. 15 here, you take out a 5, you're left with 3. So this is factorization, is the opposite of expansion. Okay, if you're not too sure about what factorization is, do come and find me, right? Seek help or do some practice on your own. It's actually the reverse process of expansion, particularly the rainbow method in this case. So let's take a look. So you have 8xy plus 16xyz. Yeah, there are two terms over here. So we are interested in finding what is the highest common factor between these two terms. Okay, so let's look at the number first. 8 and 16. Well, you can expect that the term, the highest common factor, involves 8. Okay, next we look at the variables, the letters x, y, and x, y, z. So what is the highest common factor between x, y, and x, y, z? If you write it out, right? X, y, and x, y, z. Clearly, it is x, y. In case you're not sure why, because x, y, z is simply x, y times z. Okay, so your highest common factor in this case is 8 times xy. 8xy. Okay, so if I were to factorize that out, maybe I should just show you the working. Yeah, this is the common factor, and then whatever is left in the bracket is 1 plus 2z. Maybe I should write down the original question on top so that you can see it. 16xyz. Right, this is equals to this. Okay, you can see that how it's factorized. So one thing that can help you to figure out what's wrong in the example on the left hand side, okay, is that we have a plus sign in the original expression. So when you factorize, there should also be a plus sign. Notice that if you go back to the example, you see that there's a plus sign here, and at the end of the factorization, there should be a plus sign as well. So one look at this expression given, something is wrong because there are supposed to be two terms, one term, two term in the original expression, and now you're only left with one term. Clearly something is wrong. Okay, so therefore the mistake is over here. Well, anyways, there's only one step, so that's the only mistake, right? No brainer. If you had circled, for instance, if you have circled 2z, I would have also given you the mark because, well, the factor over here is fine, is correct, but whatever is in the bracket is wrong. Okay, so here you go. That's the answer. Moving on. Okay, this is the kind of question that you're required to substitute values into some expression, right? So we should always highlight and circle the information given. A equals to 4 and B equals to -5. Whenever I see a negative number, I must be alert, right? Because something might go wrong if I substitute wrongly. Okay, so this is a over b plus b squared, where a is 4 and b is -5. So you literally just put in the numbers, yeah? Okay, here I will encourage you to put a bracket over here because it's a negative number. Now in the original question, there's no bracket over here. So actually this is the mistake, which most of you spotted, okay? Because I reminded you the difference between -5 square and, well, -5 holding square, okay? So please be careful of the difference. What is the difference? Okay, so if you have put in this as the correction, it is fine. However, most of you managed to achieve this step, but somehow your final answer is wrong. I have no idea why. Probably it's because of your calculator skills. You managed to give me this, but your answer is the same as the original working, the sample working given to you, which you should suspect, right? Why is it the same? If you are saying that there's a mistake over here, why should your answer be the same as the wrong working, the answer in the wrong working, right? Okay, so please be careful. If you have left this as 1/5, also no problem. Okay, and this is correct. This is correct, right? Okay. moving on. Okay, again, solve the following equation. The prompt here is to solve, means at the end of the day, you should get x equals to something. Okay, which is what they have over here. Just that there's a careless mistake of copying over the signs over here. Okay, so it was supposed to be a minus in between, but the person copied over a wrong sign, which is pretty common. Alright, so this is the only question with two so-called two mistakes, but they're actually the same mistakes, yeah? Okay, so the working is as below. Okay, so over here, if you're not too sure of what is the working, you know what is done over here, cross multiplication. Actually, you should already know. Alright, the 3 after you cross up, it appears here, and the 2 appears here. Okay, from here onwards, it's just rainbow method, nothing too fancy. In the next step, simply I just deal with this, the variables, keep all the variables to one side, and then I throw all the constants over to the other side, yeah, of the equation here. And you're done. You should get a equals to something. Okay, so just now over there I said that we should get x equals to something, but it depends on what's the variable, yeah, in the question. So in this case, it's a equals to something. So take your time to copy down the answer. All right, moving on. Is that the end? Yeah, that's the end of this type of correction question. Now, I would say if you do well for this type of question, do not be too happy. Okay, now most of you, you were able to do the actual working itself, no problem. But in spotting the mistakes itself, you're not too clear. You're not too great at it, right? Which is fine. Um, reason being, uh, this type of question hardly comes up, or I would say never comes up for exams. Okay, I think this is one of the first few times that I see this type of questions coming out. Okay, if it was me, I wouldn't set this kind of question. Reason being, you see, if you look at the sample working, they actually tell you what to do already. They actually solved the question for you. They did it step by step for you. The method of solving this equation is already done for you, nicely put out. Just that the only problem here is the all those cast mistakes. So once you spotted this mistake, all you have to do is to follow suit, right? You just copy over, but taking care of the careless mistake. You're done. It's actually no brainer. You may not even know how to do rainbow method from here to here. Right? From here to here is the rainbow method. You may have forgotten how to do rainbow, or you don't even know the rainbow method. But you just simply need to copy over the answer, and you're done. There's no skill involved, right? There's no skill involved in doing this question. Imagine if I have not given you the working, are you still able to do this question? Are you still able to get the answer? A equals to something. You might have difficulty. Okay, so this is as good as the answer given to you in your face, literally, right? So please don't be too happy if you do it well, but it's fine. You may know how to do this. Now, some of you, why I'm at this, right? Some of you highlighted this. Some of you circled this as a mistake. Now, my question to you is this really a mistake? Okay, let's take a look. If you think this is a mistake, let's take a look clearly. Okay, in the equation above, 9a plus 6, sorry, not plus, equal 6a plus 4. Okay, so 9a 6a plus 6, 6a plus 4. In the following step, this is what they did. They added 6 to both sides of the equation. Am I right to say that? Well, okay. You may think that, well, I add 6, right? I cannot just anyhow add and minus and subtract things. Well, you can, because you're adding to both sides of the equation. If you're adding the same thing to both sides of the equation, you're not changing the question. You're not changing the equation at the end of the day. Why do I say so? Because I can simply have moved this plus 6 over to the other side of the equation, and what will happen? What will happen? Let's take a look. If I move over 6a plus 4, so this is the original plus 6, over here, what will happen to this plus 6? Well, it would have turned into a minus 6. Can you see that? Plus 6 minus 6 is nothing but 0. So as good as gone. So can you see that there's nothing changed over here? Nothing has changed. Okay, so that means for an equation, if I have something equals to something, let me use the square instead. Okay, I can add or subtract the same thing. So for instance, if I minus b on both sides, no problem. Nothing would change. No problem. Okay. If I were to multiply both sides by something, so for instance, I have some number k. It can be positive or negative, equals to, I also multiply k to the triangle. So long as it's the same k, no problem for the equal sign. Okay, for an equation, I can multiply, divide, plus or minus the same thing on both sides of the equation. It wouldn't change anything. In fact, for this thing, if you think about it, it is the same as cross multiplication. It is the same concept as cross multiplication. Think about it, why I say so. Okay, if you're not sure, please raise during class the next time we meet. Okay, all right. Next one, word problem. Now this word problem, many of you got it as well. Even though your working is really really sloppy, like things are flying all over the place. There is no label. I literally have to search high and low for the numbers. Okay, please do your workings properly. Can label your things neatly and accurately. Okay, so let's take a look. Okay, a diagram shows rectangle BCD with the length twice its breadth. Okay, find the area of the rectangle with its perimeter is 54 cm. So perimeter is 2 times length plus 2 times breadth, yeah? Okay. So, I'm not too sure if the x is given in the original question. Let me take a look. Okay, the x is not given. Pardon me. So that means actually you should have done something, right? Here, this x, which most of you did, you added into the diagram yourself. What you should have also done is let x be the length of the breadth. BREADTH. You should have this as well. Okay. If not, the examiner would not know what x represent. Okay. Okay. So once you've labeled this length, the breadth, sorry, as x, then the length is simply two times, right? Two times of this, so it should be 2x. So you add up all the things together. So here is 4x plus 2x. Actually, it should be like the length plus the length plus the breadth plus the breadth. Yeah, equals to 54. No problem. So you simplify this instead. So let's cancel this line. Okay, so there's a step here. So you simplify the left hand side, you should have 6x equals to 54, and x is 9 cm. Okay, don't forget your units, please. All right, x is 9 cm. Now, is that all? A couple of you actually stop over here thinking that the question is over because, well, you solved for x. Congratulations. Unfortunately, no, because you're supposed to find the area, right? Okay, so here, this is the breadth, this is the length. Okay, so if I see this and I see this, you have gotten the full marks. But technically, you should have this. Okay, I only saw one. Out of the whole class, I remember only seeing one student doing this. I think it was a girl. Okay, she also write let y be the length. The length. Okay, the length of the breadth is sounds weird because length is used for the longer side, right? The word length. Okay, so let x be the breadth and let y be the length. Okay, of the rectangle. Yeah. So yeah, the student went ahead and write that y equals to 2x. Okay, which is fine, which is totally fine, no problem. You could have just worked with x alone and not introduce another y because you know that it's just 2 times of x, no problem. I think it's good practice. It's good practice, even though it might lead to some careless here and there, maybe. Okay, but this question is very very simple. Okay, moving on. This is pretty well done. Okay, so this is fill in the blanks. Again, this kind of question will not come out for exams, so please don't be too happy. And it's worth 5 marks. My goodness, 5 marks. How cheap is it? 3 marks. Okay. Now, let's take a look. Yeah. Okay, in the department store, a pair of shoes is price of $105. During the GSS, the store offers a what of 10%. Definitely is a discount, clearly. I mean, during a sales, you should expect a discount, but there are no other closer words to that. So discount, okay, of 10%. And the price of the shoe decrease naturally because if you're given a discount, the price should be lower. Yeah, as you expect in the sale. To how much? To what? No, lower to what? We expect this to be a number because there's a dollar sign here. Out of the two numbers, there's something that you don't need to do calculations. You don't have to take 90 over 100 times 105 to get an answer. You can do a guess. You can make a guess, right? This is way too low. Yeah, for a 10% discount. So 94.5. Yeah. So Mark bought the shoes. So he bought it at 95.50 and sold it to Tom. Whoa, he ripped off his friend, or maybe not a friend. Yeah. So he bought things cheaper and sold it at a more expensive price. So he made a profit. Yeah, he earned some money. Okay. So this is 5 marks. Notice that this is worth 2 marks. No, I wouldn't be that generous. Anyways, moving on. Okay. So this last question is talking about how graphs and diagrams can be misleading. We have discussed a few of that before, right? So your task here is to be the detective and spot the parts whereby the graph might be misleading, right? So this is a bar graph, okay, showing the car production in 2 years, 18 and 19. Okay, so here's the claim, right? Here's the dangerous part. The company claimed that the car produced doubled. Doubled means 2 times. Okay. Okay. So this is the claim. So when you when when you see this kind of claim, the first question is really. You should go and doubt this. Okay, because to double the sales in 1 year is insane. It's really really insane on the usual case. Okay. Okay. So usually sales wouldn't go up so drastically, because double means 100% increase, which is really really doubtable. Okay, so let's take a look. Okay, so this 5,000 is given. Sorry, it wasn't given, so I asked you to write it down. Um, I think one or two of you told me that the 5,000, the number is not present in the graph, therefore it's misleading. No, no, sorry. This is a printing error. So unfortunately, it is given, supposed to be given, in the graph itself. Okay, it's not that. Yeah, it's not that I added it in. You know, yeah, it's supposed to be there anyways. So, yeah, state one aspect of the graph that may mislead people. Okay, so do bear in mind the claim, right? The big claim. Okay, the questionable claim. Now let's look at the graph. Okay, yeah, it really looks like, 2019, the graph doubled, right? It really looks like the bar doubled. So henceforth the claim. But is that really true? No. Yeah, most of you managed to spot the problem. This is 2000 and this is 2000 difference, right? But it's different, yeah. It is not the actual number. So yeah, it's only merely a 2000 increase, but not twice of 7,000. Okay, so the answer is this. The y-axis does not start from 0, so this will give you 1 mark. Okay, the data is exaggerated. Okay, or you can say that the production in 2019 is 2,000 more cars, but it looks like it has doubled. Right? In order to double, you have produced 7,000 more. Okay, so something like this. So the first thing is the first mark goes to spotting the problem. Okay, spotting the problem in the graph. The next mark goes to how it will mislead. Okay, how this thing, will mislead people. Okay, so it's not too difficult, right? You can try to do this for the rest of the examples in the notes. Remember, we didn't really finish this section in the notes. Okay, I would say this example is pretty fun. Like you are spotting how companies are trying to scam customers, right? So please go and try. Okay, we will discuss this another time. Yeah. Okay. So that's it. This is the end of the paper. It's upon 20. I have not collated what is the average score, but quite a number of you scored 17 and above, which is great. Great for starters. Unfortunately, this is only practice, so it's not counted. Right? Don't be too happy. Okay. So for those of you who didn't really score well this time round, um, so let me just briefly tell you how I think we should study for mathematics. Yeah. So how to study for math? Number one, colors do help. Okay, colors do help. What I mean by that, in your notes, actually it works for any subject. Okay, if your notes is colorful, then it might help you to recall memory, especially for subjects that are there's a lot of memory work like science. When you're reading, when you're studying chapters on bios, there's a lot of terms, a lot of words to remember, right? So do use a lot of colors, color highlighters, colored pens, whatever. It actually helps in retrieving or taking out memory, from your brain. This is proven. Okay, this is tested. Okay. Second thing, do not just read the notes. I don't know if I've mentioned this before, but if the way that you study is okay, I'm gonna open up the notes, I'm gonna flip through, I'm gonna read through the examples, and then after reading 2 or 3 examples, I tell myself, yeah, I think I know how to do this. I think I know. If you are going to say something like this to yourself, then gone. You are very likely to be gone. Right? Please do not just read the notes, but instead you should be redoing the examples um, in the notes and worksheet. So what do I mean by that? Okay, go to the notes. Okay, what you can do is you can read the first example. Okay, with the answers you have taken down during lesson. Okay, then what you can do is you cover up the answers and do the question again on a scrap piece of paper. Just keep redoing the key here is redoing until you get it correct. Let me type it down, okay? Redo the same question until you get it correct. And that includes the working, the presentation of the working. Okay, this part here is pretty important. Do not think that you're gonna get full marks if you get the answer correct. No such thing. Okay, if your presentation is off, you're not gonna score well as well. Okay, so for the same question, after you cover up the answer, and then you start to do, okay, then you review the answer and you check for yourself. Okay, did I get it correct? Did I get the working correct? Okay, if not, redo it until you get it correct. Okay, so you just need your notes and worksheets. Really, there's no need to buy assessment books. Okay, there's really no need to. At lower sec level, there's really no need to. The notes and worksheets are sufficient. Okay, so good news. Next, okay, once you have gotten used to all this way of studying, as you practice, especially nearing the any major tests or exams, I would say the red color portions come into place. This is more like expert tips, yeah. Okay, for expert, right? Time yourself really. Um, I have many students telling me that, sure, when I do practice on my own, I do what you said at the top, but when it comes to exam, I suddenly just blank out. I don't know how many of you experienced this before, but if you are blanking out suddenly during exam, suddenly panic, don't know what to do, it's a matter of confidence. It's an issue of confidence. Um, During exam, you're put under that kind of pressure, you're put under that kind of conditions, but you're pressurized to do things within a short period of time, okay, which you are not used to, during your regular practice. So henceforth, really time yourself. Once you are familiar, once you have enough confidence, you realize that okay, I'm getting the answers exactly what I copied down in the notes, then you should go ahead and time yourself. Okay, time yourself, force yourself to do a few questions within say 5 minutes. You just time yourself. There's no high and fast rule as to how long you should be spending on a particular question, but maybe in general is about 1.5 minutes per mark. Means every 1 mark you should only spend 1.5 minutes. So um if it's a 3 mark question, then you should be spending 4.5 minutes. So you can time yourself something like this. Yeah. Okay. And of course, practice in exam setting. So exam setting refers also to the limited time given. Okay. Or maybe the environment. Don't study in a place. Try not to lah. Okay. Try not to study in a place whereby it's noisy. Um, get yourself in that kind of exam condition, to practice, so that it's easier for you to retrieve your memory. This is also scientifically proven. All right, so there goes. I hope you also do well for the actual weighted assessment. Okay, we'll go back when we meet back again in school. We will do corrections for this practice paper. Okay, we will sit down and do the corrections and analyze your own mistakes carefully. Okay, and hopefully we score well for the real one. Alright, if not, I'll see you for the next video. Take care.